everybody. Welcome back. It is April 24th. Happy Friday. Today's lesson is going to focus on organic acids, esters, and the organic chemical reaction known as esterification. So please make sure you have your table R out as we look at these two next groups of organic compounds. And actually, I'm going to take a quick look at table K today as well. Okay, so first of all, let's talk about organic acids. There are actually examples of organic acids that we are focusing on today. Of course, we're going to use table R as we continue, but some of them are actually listed in table K as well. And you're going to find that there are inorganic acids also listed in table K. So as a reminder, organic compounds contain both carbon and hydrogen, as in these two examples of organic acids, whereas these examples of acids all only contain hydrogen and some other elements. Organic acids have many uses and can be found in a variety of substances. For example, citrus fruits. Cleaners, detergents, and pharmaceuticals may have organic acids associated with them. And we will be studying acids and bases in an upcoming unit, but just to please note that acids always have a pH between 0 and 6.9 on the pH scale. Looking close at table R, here is our organic acid row. Functional group is known as the carboxyl group. And a general formula, you're going to have some group of elements, carbon backbone, attached to that carboxyl group. And here's our example, propanoic acid. Let's look at why it's called this. There are 3 carbons, propane. The propanoic acid part comes from that carboxyl group. So propanoic acid. We're going to change the ending to the parent backbone. Now, I also have shown here that, see the carboxyl group shown this way, but sometimes it's shown as COOH, C-O-O-H. That is the same representation as this, so don't let it throw you. And going back to our ball and stick model here for propanoic acid, let's take a look. Here's our 3 carbons, propane backbone. It's propanoic acid because there is the carboxyl group, double bonded O plus an OH. All right, let's look at another example. This would be butanoic acid. Well, we know by looking at table R, the ultimate cheat sheet, that we have this functional group, the carboxyl group. We have butanoic acid. There are 4 carbons in all. Here's one of them. 2, 3, 4 carbons. And hydrogens would be coming off of each of those dashes. Butanoic acid. Okay, let's move on to esters. Esters have many uses, and some of them are listed here. They can be found in synthetic flavorings, usually sweet-smelling flavorings. They can be found in perfumes and cosmetics, and sometimes they can even be used as solvents for some paints. Looking at table R, here is our ester information. The functional group here This is that carbonyl group. You actually saw that earlier on in the lesson about aldehydes and ketones. We have that carbonyl group back here. But esters are a little more complicated, and they have another oxygen next to that carbon here. So it's an oxygen sandwich with a carbonyl group. And looking really carefully at this example, this is called methyl propanoate. Let's look at that up close. If I look, where's the methyl? Methyl is a 1 carbon chain. Methyl. Propanoate, 3 carbons. Propane backbone. So when we write it though, we're going to always write the group that is next to that oxygen sandwich first. And this is tricky. I completely relate to that. But the key is, if you just look really, really carefully at your, right here, at your table R, and you just carefully look at how they named that, once you see other examples, you should be able to mimic it. There's no point in trying to memorize this. And actually, I'm always going back to my ball and stick model. Here is our methyl propanoate. Here is our methyl group, oxygen sandwich, carbonyl group, double bond, and propanoate, 3 carbons here, methyl propanoate. These were getting pretty big, and I wanted to compare several examples at one time of these esters, because esters, you know, it's pretty intimidating. I'm imagining what you're thinking when you're looking at this right now. But let's first note that this example is one that we just went over. This was methyl propanoate, okay? Methyl propanoate. So let's just compare all of these examples here. I'll just start at the top. This was a methyl. This is ethyl, 2 carbons. Ethyl methanoate, 1 carbon here, 2 here. Ethyl methanoate. All right, well, look at this one. Well, now we have 3 carbons here. It's not ethyl, it is propyl ethanoate. Propyl, 3 carbons. Ethanoate, 2 carbons. So the O8 name is the one that's connected to that carbonyl group. All right, and then let's look at this example. We've got a 1 carbon group. Ah, look at that, same. This is a methyl. 1, 2, 3, 4. Butanoate. Methyl butanoate. Okay, there is no need to memorize these, but if you do take a careful look at table R, you will be given an example and the proper naming. Just copy that methodology and you should be able to name any ester at the Regents chemistry level. Okay, up next is a chemical reaction known as esterification reaction. And this is where we can make esters or break them apart. How do we make an ester? We take an acid, an organic acid, react it with an alcohol to yield an ester and water. Notice that this is a reversible reaction. I can take an ester and add water to it and create an alcohol and an acid. We're going to go in this direction now. So you could see the esterification reaction written this way. That's nice and easy to look at. You could also see it written with the general formulas. So again, table R is going to be very useful here because our general formulas are in that third column. Let's look. This is an acid, an organic acid. It's got the carboxyl group. Reacting with an alcohol, it's got that hydroxyl group to yield an ester that has a carbonyl group and an oxygen sandwich in it. And then plain old water there. Of course, I'm going to show you a full example of this. And wow, this is going to take up a lot of space here. All right, I hope this all fits. So here is a full example of an esterification reaction. If we look carefully, by the way, notice a couple of things. I've highlighted in red this hydrogen and this OH, and I highlighted water. So let's look at it. This is an acid. How do we know it? It's got Cu, C, double bonded O, OH. What kind of acid? It's a 2-carbon acid. It is ethanoic acid. It reacts with an alcohol. We know it's an alcohol because of the hydroxyl group. And it's got 2 carbons. It is ethanol. Notice how these words have different suffixes, and that's all in table R. If you look carefully at table R, you're going to note that this would categorize as an ester. So what is this? You've got 2 carbons here, 2 carbons there. Oh, ethyl, ethanoate, ethyl, ethanoate, and water. But my last comment here is, in order to have these two react together, this hydrogen had to be pulled off, this hydroxide had to be pulled off, allowing a bond to occur between these two ends, and here they are. So here's our CH3, COO, and here's our CH2, CH3, and here's our HOH. It becomes water. That concludes the organic acid and esterification. Bye.